Hi, I'm Tatiana and I'll be talking about nitrogen and phosphorus removal from paper mill wastewater. And I'll also show how it links in with some concepts we've learnt in class, being oxidation and reduction reactions. So I'll start off by giving some context as to how paper is made. So essentially, debarked logs are ground into a pulp and then cooked in a chemical solution of sodium sulfate and hydroxide, where it is then filtered and spread onto a fast rolling belt made out of mesh screening. And finally, it's rolled out into paper. So this process uses up a lot of water. And to give you a rough idea, about one A4 sheet of paper uses up 10 litres of water. And in one office alone, they would use about 12.1 trillion sheets of paper a year. That's 121 trillion litres of water. This is relevant because wood naturally contains phosphorus and nitrogen, which inevitably will end up in the discharged waste. So controlling the amount of nitrogen and phosphorus in the water is extremely important. So while both nitrogen and phosphorus are essential for life, if unbalanced quantities enter the aquatic ecosystems, it can have devastating effects. This can result in toxic living conditions for animals and plants, oxygen depletion of the water, and eutrophication. Also, if the nutrient-abundant water is drunk by humans, it can cause lots of devastating health effects, one being blue baby syndrome, where the excess nitrate interferes with blood oxygenation, and that can be pretty dangerous. How do we get rid of these nutrients from the water? So for nitrogen, we can represent it in a two-step process, being nitrification and denitrification. So first, you need to know nitrogen is present in water in two forms: ammonium and ammonia. And because these molecules are in equilibrium, the pH affects their presence. So according to Le Chatelier's principle, a lower pH, around 5 to 8, favours the backward reaction. And since the pH of water is around 7, we will naturally have more ammonium present than ammonia. So now in nitrification, the ammonia oxidizes into nitrite, where you can see it has 2 oxygen molecules attached. And then with the help of nitrobacter, it will then become nitrate with 3 oxygen molecules. So while nitrate isn't as harmful as ammonia, it can still cause eutrophication and interfere with blood oxygenation in humans. Now the denitrification step is necessary. So this is where bacteria are used, which would normally feed on oxygen, but when they're deprived from oxygen, they feed on other compounds such as nitrates, where they strip off the 3 oxygen atoms. So as you can see from this equation, the nitrogen will bubble off as nitrogen gas, and the hydroxide will also help balance the pH. So now for phosphorus. Excess phosphorus can also cause eutrophication in water, which is harmful to the ecosystems. Phosphorus can be removed in 3 different ways. So firstly, physically by membrane technology, secondly, chemically by precipitation reactions, and thirdly, biologically. And this is the method that is preferred by paper mill effluent treatment. So they use phosphorus absorbing organisms, where essentially the organisms will consume the phosphorus as their food and leave a sludge on the surface which needs to be removed periodically. So tying this all together, to treat the paper mill effluent, commonly aerated lagoons and activated sludge processes efficiently facilitate the necessary aerobic and anaerobic zones that are needed to get rid of the phosphorus and nitrogen in the water. So where to from here? So because of the colossal amounts of water used in the paper-making process, we must repurpose them to minimise waste. 2 of the most effective methods include reusing the water for irrigation, since it's got the necessary nutrient amounts in it, and also repurposing the sludge to making lower grade paper. This not only minimises the waste that these paper mills put out, but it also is an opportunity for the companies to be making more profit.